Hello everyone, welcome to our channel. Let's learn together. In this video, I am going to explain about regular falsi method. This regular falsi method closely resembles to the bisection method. This is also one of the root finding techniques. So let's start with what is regular falsi method. So consider f of x equals to 0 is our equation where we have to find the root for f of x. Let x equals to a, x equals to b, x equals to a and x equals to b be the 2 points such that a is less than b. If f of a into f of b, that is if f of a into f of b is less than 0, then the root lies in a comma b. Okay? And let y is equals to f of x be our curve whose coordinates are a comma f of a and b comma f of b. Okay, now this is c is our real root. Now we have to find out the c, right? Now draw the chord ab, and from the equation of chord ab, that is, this is the chord equation, we have to substitute the values and find out. We see that it intersects on x-axis, that is at y equals to 0. Substitute y is equals to 0 and solve. Then you will be getting the x value as this. Now using this, we have to do the approximations. So I think this is visible right now. So using this formula, we will be doing approximations. In bisection method, we have just used the average of these 2 points, right? Instead of that, we will be using this formula in regular falsi method. So what is this formula? This represents the approximation at the point x comma 0. Okay, so that we will be finding the real root using the same process of the bisection method. Only in while doing approximations, we will be using this formula. So now let's start with our example. So let's start with our step 1. So first find out f of x. What is f of x? X cube minus 2x minus 5, right? We have to find the real root. Similar to the bisection method, choose the values of a and b. Or consider at x equals to 0, find f of 0. Substitute 0 here, what you will be getting? That is 0 cube minus 2 into 0 minus 5 is equals to minus 5, which is less than 0. That is f of 0 is less than 0. Now consider x equals to 1. Substitute 1 here. 1 cube minus 2 into 1 minus 5. It is again less than 0, right? What we have to do, we have to check f of a into f of b should be less than 0. Suppose f of 0 into f of 1, negative into negative is negative or positive? Positive, right? This condition is not satisfied. Now go for x equals to 2. Again f of 2 is less than 0. So x equals to 3. Substitute 3 in this equation. You will be getting greater than 0. Now consider these both. That is f of 2 into f of 3. That is f of 2 is negative, that is less than 0. F of 3 is positive, right? Greater than 0. Then the output will be less than 0. Minus into plus is minus, right? Therefore, the root lies in these both values, that is 2 comma 3. Now, we have to do the approximations, right? By regular falsi method. What we have to do, I have explained the formula, right? That is x1. Let us take as x1. That is a into f of b minus b into f of a divided by f of b minus f of a. This is our equation, right? What is our f of a? F of a. What is our f of a? That is f of 2, right? This is f of 2. I mean a is equals to 2 and b is equals to 3 from here, from the above step. Therefore, our first approximation will be A value is 2, right? F of B means f of B. What is B? 3. F of 3 minus B is 3. F of A is f of 2 divided by f of B, f of 3 minus f of A. F of A is f of 2. Now just substitute the values. 2 into f of 3 value. F of 3 value is 16. From here, okay, you have to calculate. I have written directly, okay. Just calculate. 2 into 16 minus 3. What is f of 2? F of 2 is minus 1 divided by f of 3 is 16 minus f of 2. F of 2 is minus 1. Minus into minus 1, okay. Calculate this whole thing. You will be getting 2.059. We have found the value of x1. Now what you have to do? Calculate f of x1, that is f of 2.059, which is equals to, substitute here in this equation, you will be getting minus 0.389, and this is less than 0. Okay, now what we have to do? At least we have to do two approximations. We have to do two approximations such that two successive approximations are approximately equal. Now we'll go for the second approximation, okay? Before that, you have to check whether f of x1 into f of 2 is less than 0 or not. F of x then is less than 0 means negative value. F of 2 is also less than 0. It is negative value. This means negative into negative positive. It doesn't satisfy our condition. So we have to take f of 3, right? From here. First we have checked with 2. Again go for 3. F of x1 into f of 3. F of 3 is a positive value. So negative into positive is negative. So it is less than 0. We have satisfied the condition. Therefore, the root lies in these both values. That is x1 comma 3. What is x1? x1 is 2.059 comma 3. Okay. Remember this. Now I am just erasing the step 1. Now I am going for the second approximation, that is step 3. Again use the same formula. I am just denoting it as x2. Same formula, okay. A into f of b. What is a here now? This is a and this is our b, okay. Now what is a? 2.059 into f of b. b is 3, right? F of 3 minus b. 3 into f of a. F of a, I think we have calculated earlier, right? F of a, sorry, f of a is f of 2.059 divided by, what is f of b? F of 3 minus f of a. F of a is 2.059, okay. Now calculate the values, that is x2 2.059 into f of 3 value is, I calculated it and it is, f of 3 value is 16. You just have to substitute 3 here in this equation, okay. Minus 3 into f of 2.059 is 0.389 divided by f of 3. F of 3 is 16 minus f of 2.059 is minus 0.389, okay. And here also a minus, that is f of this value, f of 2.059 value. Now calculating this, you will be getting x2 value as 2.0813. Now what you have to do? You have to calculate f of x2. F of x2 means f of 2.0813. Now check whether x2 and x1 values are approximately equal. This is x1, 2.059 and 2.083. No, they are not much approximately equal. You have to go for third approximation, okay. So if you calculate f of x2, you will be getting the value as minus 0.1489, which is less than 0. Okay. Okay, should I keep this formula? Okay, I'll erase. So, okay, fine. From first approximation, we have seen that the root lies in 2.059, 3, right? Just remember this. Now, what you have to do? This is f of x2. You have to check whether f of x2 into f of 2.059 from the first approximation you have calculated, right, is less than 0 or not. F of x2 is multiplying these both values, you will not get less than 0. Okay. So this will be greater than 0. This will not satisfy condition. Therefore, go for f of 3. F of x2 into f of 3. This is negative value, right? F of x3 is less than 0, negative. F of 3 is greater than 0, which is a positive value. Negative into positive results in negative. Therefore, less than 0. Therefore, the root lies in these both values, that is x2, 3. What is x2? 2.0813, 3. Okay. I have told you that we have to go for third approximation, right? Now we'll be going for third approximation, x3. I hope you remember the formula. This is A and this is B. What is the formula? A is 2.0813 into f of B. B is 3, f of 3, minus B into B is 3 into f of A. F of A is 2.0813 divided by f of B. F of B is f of 3 minus f of A. F of A is 2.0813. Just calculate, substitute all the values, that is 2.0813. F of 3 value is, I think we have calculated here, right, into 16 minus 3 into f of 2.083. Calculate, that is f of 2.083 value is minus 0.1489 divided by f of 3 is 16, right, minus f of 2.0183, that is minus 0.1489. Calculate this, you will be getting 2.0896. Now check whether x3 and x2 are approximately equal or not. Yes, 2.0813 and 2.0896 up to 2 decimals, they are approximately equal. Therefore, you can stop the process. Therefore, x2 and x3 are approximately equal. Therefore, the root is 2.0896 approximately. So this is all about the regular falsi method. Thanks for watching. Do like, share and subscribe for more videos, and do check the playlist of mathematical transformation techniques course for all the videos I have uploaded there. Thank you. Bye.